So today we use some, maybe the first time you will run some CNN. Have you already run some CNN? Not yet? Okay, so you have this slide and you have the R code, is it? Okay, you have all of this. And also I put something on the website too, on the, in our map, you have a cheat sheet on the CNN, is it? You got this? On the file? Yes, Machine got it. Apparently not Han. You got it also? Okay. So maybe it's just some, it could be useful, it's quite nice. And maybe, yes, for some people who are not familiar with RStudio and something like this, like Matt, but now he's familiar. Do you have a, can you see my RStudio or not really? When I put like this now? You only see the HTML now? Is it HTML or is RStudio you see when I share?
We can see the RStudio.
Okay, so if you go to RStudio, you can go on the top when you have help. You can see, you see help, and you have sheets, cheat sheets. You see it? Cheat sheets, and it's quite nice because you have plenty of different summary for different topics. So if you want to write some report, for example, with R Markdown, you click here, up, and you arrive with a nice PDF, which is like this, something like this. Yep, you got something like this. So there are different topics like this. It's quite good. Okay, maybe everybody knows this. So I managed to get the one from Keras. Okay, so we have some, we have a challenge today, and we need to be good because remember that next week we'll organize a challenge between Python and Julia. So at the end of this task, you will try to run by yourself some different CNN on this data to improve the result. So I've done something basic very quickly and I got a result, and I hope you will be better than me. Okay, this is the goal. Okay, so load the data. You know how to load the data. You managed to do this? Tell me if it's okay. Oh, Seabox. Okay, yep. All was good for this. I hope I didn't do any mistake. So you can see that it's funny because in this Spark we do some image, but we don't see any image. Eh? But you know the image. We can, you know, also to plot some image. But okay, so keep in mind that I have a good laptop, a Mac with a kernel Linux inside, and it's quite a recent laptop. So maybe it will be faster than your laptop, I don't know, or your computer. So it's just to be comfortable, to use a good function to run a CNN. So I have on my code here, I have chosen to train with 8,000 images and 4,000 for validation. Okay. And the test set, we will use all. But if you just to try at the beginning, maybe you can have a shortened length for the train. You see this train validation is okay? So if it's too long, or if your computer does start to be, you don't want this noise. So okay. Okay, so anyway, I just do some selection of the data. And this is a code. We don't need, we will talk about this. So Keras, sequential, you remember this? We have in our data when we have some image, it was 32 by 32. So I put a sequential kind of bunch of different layers, as you know, and there are some instructions. So for the first one is filter 8, kernel size 33, stride 11, padding same, blah, 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 blah. Do you you know what is the meaning of all of this? Okay, so what is the meaning after this convolution, this first layer, what I will have? For example, after this, what I ended, what kind of data I have, structure, or whatever. So I will spend a little bit of time on this because on the quiz 2, it will be, I'm sure, easy one. We say easy. It will be this kind of question. Okay, to say the number of neuron or number of parameters and so on and so on. So you need to be comfortable with this. So at the end of this first layer, we get up with 8 channels. So is 8, in fact, is 8 matrix 32 by 32. Everybody agree with Anne?
Yep.
Okay, just after we do a batch normalization. We haven't talked about too much about batch normalization. Is on the note. It was not clear because Matt asked me some question during consultation hours, some good question. So the batch normalization is a little bit different for the fully neural network, deep neural network, and the convolutional, but is meaning that after is depending, but after the activation, after going to the next layer, they do some normalization. And to do some normalization, the neural network will use 2 parameters, the scale and the shift, which will be learned from the process. So it's 2 extra parameters. And these 2 extra parameters are in the convolutional neural network are 2 for each. Remember, 2 for each channel. So after the batch normalization, we will end up with 2 more parameters per channel. Clear enough? And if we see the summary, you can see that, I hope it's okay. Oh my God, yes. I knew it told me why is 32. Okay, I saw this. I saw this on the Keras, because Keras keep in mind two extra parameter from is a computer in a computational trick. So normally it's 2 parameters per channel. So it's 2 times 8, it should be 16. But in the implementation of Keras, let's see, friends. Yes, good point. I wanted to talk about this, of the padding. Okay, so the batch normalization, keep in mind that in reality is 2, but it's just a kind of implementation you need to track. So I will give more for everyone on the lecture tomorrow. Why is in Keras is 4 times 8. But keep in mind, normally it's 2 parameters to normalize each channel. Okay? So it should be 16, but it's just a trick on Keras in I don't know if in every software package. So we'll talk about the padding, okay? On the padding, okay? And I don't know if Yoni, I told Yoni to give you this information. I don't know if he gave you this sheet, CNN. Okay, this one is quite, and you have the PDF. He gave you this information or not? You see or not? I will put this link here. And this is from a course in Stanford. These 2 guys is some twin. They did some cheat sheets for convolutional network. And it's quite nice because he explained very quickly what is a convolutional, blah, 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 blah. And he give you a brief summary of the pooling and the marks, the illustration, quite nice. You see my screen or not? You see the link, and you can get the PDF of this. And why it's quite nice is also because we talk about the padding and all of this. And so the padding is writing here. You see, valid, same, and full. You see this mode? Oh, I just sent the link, not to everyone. Okay, sorry, very clean. Len, thanks, Len. Yep. Ah, I sent the link to everyone. Sorry, I just want talking with Len because I just like Len. Len is my friend. Okay, you got it? Yes. Okay. Perfect. So I think it's quite. I like this cheat sheet. Okay. So in the padding, remember we have valid, same, and full. So what I've done on this one, I put what valid. No, same. I put same. So if I put same. Yes. As I put same is meaning that the padding such that features map size blah blah blah. Is also called half padding. Yeah. So I think Anne reply padding same means that you will get the same dimension of the output and the input. True. Good. So after this, I did again max pooling. No, I put a max pooling. So after the max pooling, you should have how many parameters when you do a max pooling? How many parameters you add when you do a max pooling? Why? Do you agree with Anne? Okay, so this. Okay. Bad. My fault, but maybe also a little bit your fault. I will again ask you my question. How many parameters to estimate you add when you do a max pooling? How many parameters you add at your neural network? How many parameters? Okay, so if somebody need to talk to me about what is the meaning of max pooling. What we do when we do max pooling? Reducing the dimension. Very good. So you reduce the dimension. So I'm going on this. What is the pooling? Max pooling. Pool. How many parameters you have more? Number of parameters, 0. You reduce the dimension. You don't do anything. You reduce the dimension. So is the meaning that on the 2 by 2, you move, you take the max of your value. This is a process. And you put, but you don't estimate a parameter. Make sense? So they don't have more parameter. No parameter. Okay? Make sense to everyone? So convolutional, yes, you add some parameter. Pooling, you don't do any parameters. Clear for everyone? It's clear? No mistake on the quiz too, on this. Because you will have this question on quiz 2. So no mistake. Put in the note, max pooling, no parameter more. But you downsize your data for the next layer. So next layer, filter 4, 3 by 3, stride 1 by 1, padding valid. So padding valid, it changed. So you need to keep in mind what is the meaning of padding valid. Remember what is padding valid? Yes, 0 padding. Okay, so now it changes the dimension also of your, it will change the dimension of your number of parameters when you do padding 0. So you have the calculation here, the number of parameters. So you can do your own calculation or your notes and all of this to understand how many parameters. And after this batch normalization, after a layer flatten, what is the meaning of layer flatten? How many parameters we add after a layer flatten? How many parameters? 0. Yes, layer flatten, you have your matrix or whatever your, and how many there after, before the layer flatten? It was 2 by 2 and max pooling. Yes, and it was how many filter? 4. Okay, so yep, you flatten. And after you do some dense layer with activation function, and you need to put the unit and so on. And which is quite nice with Keras, when you do summary model, you have all the architecture of your model. But when you're looking at this, your work is to really understand what you should be able to do this summary by yourself. So this is the aim of on this tutorial. You should understand the number of parameters after each step. Let me know if something is not clear. Or you understand the number of parameters, blah, 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 blah. And you have this number, the total number of parameters. It's kind of question we will ask you on the quiz too. Okay? Okay. Ah, good point. He put non-trainable parameter. I never seen, I forgot to say this. Remember, I told you that when you do batch normalization, normally is 2 per channel. But here he put the double, 16. Okay? So there are 16, we are not trained. He call it parameter, but it's not a parameter. It's not trainable. Okay, and after there are also, I think, say here is also here is 8. So 16 plus 8, 24. 24. Yep. All good? All good. Okay, all good. Task 0. Try to understand the dimension of the layer and the number of parameters involved. I've done. Okay, this is not compulsory, but is I found this guy who did some way to visualize some neural network. But as this neural network is, we see that when we do recurrent neural network, we can have some arrow coming and so on. So more fancy. So this is just like layer. It just tell you, oh, I did a convolutional, batch, max pooling, convolutional, batch, and so on and so on. Okay, just for the report. Okay, task 1. Modify the model to have a 5 by 5 convolutional layer in the first layer. No max pooling after no padding for the convolutional layer. You will need to update the number of neurons in the dense layer. Not so sure because Keras you don't need. Call this model model 2. So I've done. Try to get the same thing. So this is your task 1. You get it? Everybody is working on? Or you're already done? I can see one face, and the other are all. I don't see any screen, so I don't know if the people have done or not.
Just with the number of parameters, is that just for the 224, is that when you
200.
times?
Okay. Where? Task 1 or task 1 or task 0? Where you are, Peter?
Just back where we were before.
Yes.
On section 1.3.
Yes.
Is that's where to get that 224, you're timesing the number of filters, so the 8, by the number of elements in the kernel. Is that one for the number of parameters?
Okay, so we will work all together. If somebody can help for Peter for the 224, is somebody know? And this doing the job?
Yes, thank you.
Yep. All good? So 3 pop 3 plus 1 times 28. 28. Yeah. Good job. All clear, Peter?
Yes, thank you.
Okay, good.
Yeah, it was right there on the cheat sheet. It looked quite nice on that you just showed on the HTML.
This one?
So
Yes.
number of parameters looks, yeah.
Yeah. So F by F by C channel plus the bias multiply by, no, this is the filter, yes. Pas filter, yep. That's good. Okay. Okay. So who managed to get the same thing here? Anne, you manage? You told me. Matt, did you get this one or not really?
Yeah.
Yeah. It's a small yeah, I'm not sure. I trust.
Yeah, I think I've got the one before it.
Okay.
It's all good. I'm going at my own pace kind of thing.
Okay, so now we need to, if you manage to do it, I'm sure you can now train your model. So to train your model, remember, we need to use compile. I use the loss function categorical cross entropy because we have, why it is classical? Yes, we have chosen three kind of image. Remember, it was what we have chosen. I remember a truck. What we chosen? I don't remember. Airplane, cat, and truck. So we just use 3, so it's more than 2. So the loss function is categorical. I use a metric accuracy. I chosen like Adam, but you can choose something else. And with 20 epoch, batch size 50, I put this just to know if it will be long for you or not. And this is running with this number in 38 seconds in my computer. I don't know if you got something similar. Did you manage to run your model? Oh, not too bad. So I'm try with 2009 currently running. Okay, Len. And you run with how many training? You put 2000 and 1000? 2000 training, 1000 validation? Ah, same as the original R file. Ah, it could be very long, we'll see. Okay. Yep. By the way, I don't like, we were talking about this with Yoni. I don't like the terminology about on the deep learning But you know that we split the data in training, validation, test. But when if we say always training, for example, if you download this data, you have a training set and a test set. But after the training set, you also cut the training set in training and validation. So for us, the terminology is not good. We are thinking about to write, say, unseen data and seen data. And the seen data, you cut the seen data in training validation. Because sometimes it's confusing, training data, because the training data, in fact, you use it apart on the validation. Okay, it's just a philosophy. Okay, so what, okay, can I see one figure from somebody on the history? Do you get through, Len? Is still running? Whee, very good. Okay, 1 minute. Okay, not too bad. So what happened on this data? You can see that it's training pretty well. It was the loss going down, the accuracy going up. And on one stage, you can see that it looks like overfit at one stage. You can see it? Yeah. So maybe we will use an early stop later or something like this, because it starts to be pretty bad after, I don't know, 12 epochs. You see this? Okay, it's clear for you? Okay, I evaluate my model. To evaluate the model, I have used just a different function. I use evaluate from TensorFlow. And with this code, I managed to get my confusion matrix, and I calculate the accuracy, and I got this 0.77 on first shot. Not too bad, but did you get something like this? So we do a lot of error. For example, we say 16 times, we say, oh, it's an airplane, but it was a cat. So what is your accuracy? Can you give me some numbers for the accuracy? Mine is really bad. Oh my God. Yes, because I think it's because you don't have a lot of training data. So you should run with, yeah. Okay, Len gets the 70, okay. Okay, task 2. Attempt to create a different model architecture, use 2 additional convolutional layers, try to maximize the validation accuracy. And I just play, you don't see my model. Hide my model. Hide the model. And my accuracy going a little bit down the loss, you can see, but still a little bit of overfitting. But after, if I stop after 2 epochs, I think I could be around the 0.8. And when I evaluate my model is here, is a little bit better. I got 81. But not with all the data. I can also use more data, because I have used 8,000 and 4,000 for validation. Okay, so now it's time to play. Show me more. You need to add some 2 additional convolutional layers.
So, sorry, how did you check the accuracy on the ones we were doing before? I didn't see any accuracy measure coming up. Or did we have to add something else to get the accuracy?
Okay. Just I just show, because so you can use directly a function which give you if you do because I didn't plot, But if you plot, if you run this code here, model hack, and after you type model.rcc, you will get the same value as here. But I'm computing by myself because the accuracy is the diagonal. You can see I take the diagonal of my coefficient matrix because this is the true finding, and I divide by the number of my test set. Make sense? So I have added 551 plus 934 plus 845, and I divided by 3000, and I got this value. But this value should be exactly equal to model.rcc. I reply to the question.
So it's just using that first line of code in 1.8. That's how you would get the accuracy.
Yes, you can. Okay, you can go like this because in the result of model.rcc, I think you have the accuracy. Okay, try this. But I also the accuracy I compute by this line of code. You see with my mouse or not? Just before the 1.9.
Yes.
So it will give you the same result. Otherwise, it's just because I wanted to do this to show you that you can predict with your predict class. I use predict class, but when you give the test, the features, the image of the test, and predict, and in pred you have the predict class. So you can run step by step this code line to understand really what's going on. A question of len. Batch normalization normally should help. You can do your free len is a free tutorial. It's like you enjoy to try because you can see that is an art. We don't know exactly what will be better, so we need to try a little bit. Maybe the learning rate also should be changed a little bit, but I don't think so. And after I will check what I have done. I don't remember exactly my. I will give me my solution after. So, do you have somebody which are completely lost? What happened? I remember Mashid had some trouble with the computer. Is better now the computer, Mashid? I remember you had some trouble.
Hi, I could fix the troubles with previous session, but today when I tried, I could work until the plot, and when I tried to do the plot again, my session expired.
Oh my
I'm
God.
running the code from the beginning again.
Again? Oh my God. But you managed to go from last time, you managed to solve your trouble or not really? No. Yes, no?
Yes, I had to set my system environment to something like this. I will copy it and paste it in the chat because your voice breaks up a lot.
Ah, okay. So today you still have some trouble, is it? You cannot hear me well? Let me know if you can.
Sorry, your voice breaks up a lot for me. I cannot hear you.
Oh, okay. And the other student, my voice is okay, or you cannot hear me? You can hear me or not really? Ah, okay. Apparently it's okay for maybe Is your it's okay for everyone, so it should be your computer. Sorry, machine. So what about Andrew, Shun, Drew? All is going well, or
For the new layers, how should we, do we just like try new filter sizes and the new hyperparameters, or is there a way to kind of know what are good numbers to put for the two new convolutional layers?
not really? So you add some convolution with a kind of number of filters to see if it's improving, because it's like a balance of number of parameters to add. Because if your model, in fact, if your model is more complex, more parameter, you should have more capacity to learn on your data. But also, if you have too many, if you add too many parameters, you might go in some trouble to due to the size of the training sample to get a good estimate. You know, so it's kind of balance. So I suggest you just to add two layer, which was two convolutional layer, and try to see the different number of filters to see what is going on. And after working on this to improve. Check what I have done. I don't remember, because I remember I've done this, I don't remember, this week I did. Tutorial 6, what is it, tutorial 6? Oh, tutorial 4. No, it's tutorial 6. I don't remember, 5. Oh yeah, for it. Tutorial unit 6, but is a unit 4. Okay. So what I have done, I have added blah 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 blah. Yes. I haven't talked about this also. Maybe you see my screen, huh? So I have done, I add a convolutional with 6 filters. What was before? So before it was 8 filters, 4 filters. And now what I've done, I put 10, 6, 6. Yes, 7 by 5, 5 by 5, 6 and 6. We need 6 solution. Maybe we take some time here, we'll see. Okay, we still have 5 minutes. I hope we'll get some. Okay. I just got 74 for model 2. And what about model 3? And somebody got try to beat me. Model 3, I just replicate twice the second correction otherwise model 2 with batch validation, no max pooling. I got an accuracy. It took me 3.5 minutes. I got 74. Okay. We need to be a strong team, remember? 74 with Anne. How many training you got, Anne? 4,000 for the training. Okay. Mine is still. I will run it. I will see. I hope it will be not too longer. Sure, model 3. Yes, 2000. I think 2000 training is not enough to get more accuracy. How long it took for you, Shun, to run? 46 seconds. Okay. By the way, on the homework too, you have some warning to do, huh? On the using some package or this will be take some time. So I advise you when you're using R, sometime to run in a batch mode. You know what is the meaning of batch mode? The bias is initialized by default to 0. Okay, but keep in mind that if you do to initialize the weight, you need because by default is on uniform. But if you want to put some, we saw last time, if we want to draw some weight from normal distribution, you need to specify it. Do you know what is the meaning to run R in a batch mode?
No, I don't think so.
Okay, so is the meaning that you have you are on Windows, Len, or Linux or Mac?
Yeah, Windows for me as well.
Windows. Okay, you can do it also. I need to give you some information. In fact, is the meaning that you write your code in the R file, and after you run, but not by opening R on Windows. You run on a terminal. So is on Windows you can run it out. I don't remember what it's called. So you don't need to open R. So he's running on the background on your orientor. You don't stack all your orientor, and you can run for the line. Yes, the common prompt. Yes, exactly.
So it's just eliminating our studio and that sort of interface things going on.
Yes,
So it's
exactly.
faster.
So,
Yeah.
yes, it's run on the background, and you can run during the night or whatever. And you can also run on file in the follow. So is the meaning that you can run when a file is finishing, you run another file and so on and so on. And is give you the result in an output file. You never done, nobody have never done this now. I always do this. Perfect. So you do this in what you use Windows, Anne, or you have Linux or whatever. Linux, okay. So you do R, CMD, and a file, is it? No, not CMD. What is the function? I remember. No, you don't need to. Ah, yes, but even you don't have to open R in terminal. Do this. So I will give you a link about this. You even don't need to open R. I put this on my book. I wrote run R in batch mode. Command line. So you have plenty of this like this. Okay. So you have plenty of examples. So it's the meaning that you, I don't know if you see my mouse, is if R is recognized by your system, if you're on Linux in a terminal, okay, this is the solution. I will put online after I run again. So just to see my network. Task 2, task 2. Yes, task 2. But the model I've done. Easier. The model I've done, I do. Okay. Conventional 5x5, filter 8. And after max pooling, batch nomination, batch pooling, filter 4, 3x3. Yes. Flatten, layer dance, layer. Okay. So this, no, it's task 1. I say, oh my God. Where is the task 2? Task 2, yeah, I didn't get it. Okay. So, filter, 10 filter. After I go to filter 6, dense 120, 60, change a bit. Okay, and you have the solution when I got, oh, I changed the accuracy now. Oh my God. The accuracy is bad now. It was 0.8 last time. It's really depending. Okay. So I hope you get the goal. Try to, because I will forget, I will put on the canvas, please put on the canvas a question about run R in the batch mode. I will not forget, and I will give you some link and how to do it. It can help. And you try on a small, because I will not get any time on 8 minutes to do it. And you try to do it in a small example, even not in Keras, with another file, and to see if it's working. Okay. So put this on the canvas, and tomorrow I will feed and give an instruction. Okay. Make sense? Sorry, we're a bit on the rush. Yes. Ah, in the previous session, I didn't give the solution also. Yes. Okay. Our code task in the previous practical session. Okay, session 4. I didn't put the okay. Yes, I will do now and send to Len. If I forgot, put on the canvas also, because when you put on canvas the question, Sarat look, and Sarat send me an email, and I do it. Okay. Okay, perfect. So I will do this. I will not do chapter 4. Is it chapter 4, lecture 4? Okay, chapter 4, lecture 4. It was what it was. Practical. Unit 4. Tutorial. It was on mist. Yes. It was this one. Is it? Okay. Ah, yes. I can do just now, in fact. Okay, what I'm doing, I will do it now. Don't move, don't leave. I will put you on the chat now. Okay. Don't leave the chat. Fast location. Okay. So, I will do now. So the function is knit r dot dot, and I think it's perl. Yes. So this line of code, in fact, what I'm running, when you have your RMD, and if you want to just get the R code from the RMD, you just do perl. What is tutorial fashion image RMD, click, and I will put R code solution prac 4.r. Click, done. And now I will give you to everyone. Everyone. Direct message to everyone. File. Up. Don't move. And let teaching. Andy, tutorial, prodigal, useful, and code. Yes. Okay, did you get it? Yeah, okay. Do you want the R code from today also or not?
Yes, please, if you could.
Okay, so I'll put we do now, because if I'm not doing now, after I will forget each session what it was. Tutorial. One, okay. So session to source file location, flag, tag. Come on. 2 minutes, and we need to change the zoom, eh? You know this, eh? Need R curl. Solution. Code solution. In fact, is PAC 5. In fact, eh? Okay, PAC 5 dot. Okay, done. Okay, don't move, don't leave. File. Okay, tick. Vertical. Is it? Okay, you should have. All good for everyone? We move? See you soon. I hope to see you all, 9, okay? We change the room. Okay. See you. I'm leaving, I'm coming. Okay, bye.